This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 1, Lesson 7, Evaporative Cooling and the Wet Bulb Line. Spray water into warm, dry air, and the air cools itself by evaporating that water. On the chart, the state rides a line of constant wet bulb temperature. Dry bulb falls, humidity ratio rises, and there's a hard floor. You can never cool below the entering wet bulb. We'll set the process, define the saturation effectiveness, and find the leaving temperature. Concept 1. The constant wet bulb line. Water evaporating into the air steals its latent heat from that same air. Dry bulb falls, so the state moves left. Humidity ratio rises, so it moves up. Together it climbs the constant wet bulb line towards saturation. And because wet bulb barely changes, enthalpy is nearly constant. Note the contrast with a wet coil, which move down and left. Evaporation moves up and left. Concept 2. The floor. As the air saturates, evaporation slows and finally stops at 100% relative humidity. That saturation point lies on the same wet bulb line, so the lowest dry bulb you can ever reach is the entering wet bulb temperature. A perfect cooler would drive the air fully to saturation. A real one falls short. The Handbook's added water balance shows the enthalpy barely changes. That's why the line is nearly constant enthalpy. Concept 3. Saturation effectiveness. It measures how far toward the floor the cooler actually drives the air. The actual dry bulb drop over the wet bulb depression. The Handbook writes it as a percentage. As a fraction, the leaving dry bulb is the entering minus effectiveness times the wet bulb depression. The driver is the wet bulb depression, not the dry bulb range. And keep direct versus indirect straight. Direct adds water and raises humidity ratio. Indirect is sensible only, so the supply air's humidity ratio stays put. Setup. Hot dry air enters a swamp cooler at 95 dry bulb, 65 wet bulb, through a pad rated at 0.85 effectiveness. The wet bulb depression, the driver, is 30 degrees. Wet bulb holds near 65 across the cooler, so only dry bulb and humidity ratio change. Solve. The wet bulb depression is 30, leaving dry bulb is 95 minus 0.85 times 30, 69.5. The air cooled 25.5 degrees, while its wet bulb held at 65, landing 4.5 short of the floor, exactly the 15% the pad leaves behind. Always check the answer sits between the entering dry bulb and the wet bulb floor. The humid day contrast. Same cooler, same 95 dry bulb, but now an 80-degree wet bulb. The depression collapses from 30 to 15, so the leaving air is only cooled to 82, less than 13 degrees. The pad rating never changed. The device is just as good. What shrank is the wet bulb depression. That's why swamp coolers win in the dry southwest and disappoint in the humid southeast. Traps. 4. 1. You can never cool below the entering wet bulb. Any answer under it is wrong. 2. Effectiveness divides by the wet bulb depression, not a dry bulb range. 3. Direct cooling raises humidity ratio, indirect leaves it unchanged. Don't mix them. 4. Effectiveness is a device rating, not the temperature drop itself. The drop is effectiveness times the wet bulb depression, so a humid inlet cools far less at the same rating. Quick recall. Direct evaporative cooling rides the constant wet bulb line. Dry bulb down, humidity ratio up, nearly constant enthalpy. Effectiveness is the actual drop over the wet bulb depression, and the leaving dry bulb is the entering minus effectiveness times that depression. Direct raises humidity ratio, indirect leaves it fixed. Golden rule. The driver is the wet bulb depression, and the entering wet bulb is a floor you can approach but never cross. Next up, Lesson 8. The sensible heat ratio. This lesson wrote a constant wet bulb line. Next, we characterize any process by how its load splits between sensible and latent. The sensible heat ratio sets the slope of the process line and ties the cooling coil back to the room it serves. Everything's at peprepengine.com. Cheat sheet, work solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.